वेलकम. मागील लेक्चरमध्ये आपण मागच्या सिक्वेन्सच्या लेक्चरमध्ये what is the definition of sequence and what is the convergence of a sequence, and some we take examples. Okay, in lecture 2, in this lecture, so now we are going to study here. So what is a bounded sequence? Bounded sequence. What is a bounded sequence? Before that, so what is the bounded above sequence? Bounded above sequence. So what is the bounded above sequence here? Okay. So what is the definition? Definition. A sequence Sn is called a bounded sequence, is called bounded above sequence, if there exists a real number m, if there exists a real number m, such that Sn is less than equal to m for all n here, for all natural numbers. Okay, so what is the definition of bounded above sequence? A sequence Sn is called bounded above sequence if there exists a real number m, capital M, such that Sn less than equal to m for all n. So we understand this definition simply taking a simple example. Okay, for example, so 1 upon n. So what is the sequence? Put n is equal to 1, then 2, then 3, then 4, and so on. So this is the sequence here. So is it bounded above sequence? So this is bounded above sequence. So we take here m is equal to 1. So this m. So this is upper bound. Okay. So we take m is equal to 1. So then for all n, each term, so this is S2, S3, S4, all terms of sequence less than equal to 1, less than equal to 1, m. So this sequence is called bounded above sequence. So this is a very simple example of bounded above sequence. Similarly, what is bounded below sequence? Bounded below sequence. Same definition. So what is the definition? A sequence Sn is called bounded below sequence if there exists a real number m, small m, such that okay, Sn less than equal to small m. इथं बघा काय आणि इथं बघा for all n. Okay, for all n. So what is the definition of bounded below sequence? A sequence Sn is called bounded below sequence if there exists a real number small m, such that Sn greater than equal to small n. small m. So we understand this definition by using simple examples. For example, sequence 2n, something 2n. Okay. So what is the sequence here? Put n is equal to 1, 2, 3 natural number, current dominant natural number. So that is 2, 4, 6, 8 and so on. Okay. So this is sequence. Okay. So why this sequence is called bounded below sequence? Okay. So what is m? Small m. So this is m. 2 is m here. 2 is m here. Now all terms greater than equal to 2. So that is small m in this sequence. So this sequence is called bounded below sequence. Okay. So you learn here bounded above sequence, bounded below sequence. So what is the definition of bounded sequence? So bounded sequence is what here? So bounded sequence. Okay. The sequence Sn. The sequence Sn is said to be bounded, sequence, okay, if and only if there exist, capital M. So this is a real number, capital M belongs to R, M such that mod of Sn is less than equal to M for all n. Okay. So Sn is a sequence. It may be त्याचं काय असेल पॉझिटिव्ह निगेटिव्ह टर्म्स असू शकतात. त्याचं मॉड्युलस घेतलं आणि एखादा नंबर मी घेतलेला आहे तिथे एक नंबर नक्कीच कुठल्या एखादा नंबर असेल की एखादा कुठलाही नंबर असेल दॅट इज एम रिअल नंबर असेल तर मॉड ऑफ Sn लेस दॅन इक्वल टू एम देन द सिक्वेन्स Sn इज बाउंडेड. कारण का एक नंबर आहे कुठला तरी एक नंबर असणार आहे तर ते सगळे नंबर्स त्याचं मॉड्युलस घ्यायचं सगळे नंबर्स लेस दॅन इक्वल टू एम असं जर असेल त्या सिक्वेन्स मध्ये सगळे नंबर्स लेस दॅन इक्वल टू एम देन द सिक्वेन्स इज कॉल्ड बाउंडेड सिक्वेन्स. ओके. आता आपण याच्यापूर्वी व्हॉट इज द कॉन्व्हर्जंट सिक्वेन्स आणि व्हॉट इज द डेफिनेशन ऑफ कॉन्व्हर्जंट सिक्वेन्स आणि इथं काय शिकलो आपण व्हॉट इज द बाउंडेड सिक्वेन्स हे आपण शिकलेलो आहे. आता इथं प्रश्न असा निर्माण होतो की इज इट कॉन्व्हर्जंट सिक्वेन्स इज बाउंडेड? इज इट convergent sequence is bounded? So we take a theorem. Okay. Theorem. Every convergent sequence is bounded. So this is a theorem here. So what is the proof? Okay. So what is the first we take? So given that the sequence Sn is convergent and then we prove that sequence is bounded. आता तुम्हाला डेफिनेशन माहिती आहे कॉन्व्हर्जंट सिक्वेन्सची आणि बाउंडेड सिक्वेन्सची डेफिनेशन आपल्याला माहिती आहे. त्या डेफिनेशनचा आधार घेऊनच या ठिकाणी आपण हे प्रूव्ह करणार आहोत. सो गिवन sequence Sn is a convergent sequence. Sequence Sn is a convergent sequence. So what is the definition of convergent sequence? So that is the limit of Sn. So this is simply notation of limit here. So this is equal to n times to infinity is equal to n. So what is the epsilon definition of a convergent sequence? And then by definition, for epsilon positive, for epsilon positive, there exists n such that mod of Sn minus L is the limit, less than equal to epsilon, where n is greater than equal to n. So n is integer. Okay, so this happen after n, then the L is the limit of sequence Sn. This is a convergence. Okay, so we all studied that. Okay, so now choose epsilon. We take epsilon is equal to 1 here. So this equation becomes, what happen here? So mod of Sn minus L is less than equal to 1. Okay, for all n greater than equal to n. Okay, let us consider. So let us consider. So mod of Sn. So we write this mod of Sn. हे आपण विचारत घेऊ. Okay, आपल्या मर्जीनं. So okay, this is mod of L plus Sn minus L. So L get cancelled. Sn as it is. Okay. So this can be written as. So this is less than mod L plus mod Sn minus L. Why it is? कारण आपल्याला एक inequality माहिती आहे. So what is the inequality? So mod of A plus B is less than equal to mod A plus mod B. So this is inequality. So this is A, this is B. So mod of A plus B is less than mod A plus mod B. So that is Sn minus L. Okay. So by using this, so what is here? Mod of Sn minus L less than 1. So this equal to, so that is mod of Sn is less than L plus 1. So for all n greater than equal to n. एक आपल्याला रिलेशन या ठिकाणी मिळालेला आहे. So now if we take m, so m is equal to, so what is the m? So this is a maximum of mod S1, mod S2, mod S3 and so on. Okay, आपल्याला sequence माहित आहे. What is the sequence Sn? S1, S2, S3, S4 are the members of that sequence. ते तर नेगेटिव्ह पॉझिटिव्ह असतील, काही असतील. But we take here set of mod S1, mod S2 and mod S3, and this is a set here, and taking maximum of that set is m here. Then we have mod of Sn is less than m plus L plus 1. M plus N plus 1. And certainly, कारण का mod of S1, S2, S3 less than S1, S2, S3, S1, S2, S3, and M is the maximum of that. Okay, त्यात सगळ्यात मोठा कुठला m असेल त्याला m म्हणतो. मग certainly if mod of Sn is less than n plus 1, certainly mod of Sn is less than m plus L plus 1. Clearly. Okay, so we say, so this is something big M. big M. So where n belongs to R here, okay, big M. And this is the definition of bounded sequence. मगाशी मी दिलेलं होतं, sequence Sn is said to be bounded if there exists a real number m such that mod of Sn less than m, then the sequence Sn is said to be bounded sequence. So we start from here. Sequence Sn is convergent and prove that that sequence is bounded. Therefore, every convergent sequence is bounded. Hence the proof. Okay? Hence the proof. Okay. So we learn here what is the bounded above sequence, bounded below sequence, and bounded sequence. And take one more theorem on bounded sequence. So next part is, what is the monotonic sequence? Monotonic sequence. Monotonic sequence. So what is the monotonic sequence? A sequence which is either increasing or decreasing, then the sequence Sn is called monotonic sequence. So either increasing, एखादी सिक्वेन्स इंक्रीजिंग असेल किंवा डिक्रीजिंग असेल तर त्या सिक्वेन्सला मोनोटॉनिक सिक्वेन्स असं म्हणतात. सो व्हॉट इज इंक्रीजिंग सिक्वेन्स? इंक्रीजिंग सिक्वेन्स आर नॉन डिक्रीजिंग, that is a non-decreasing sequence. Non-decreasing sequence. Okay. So what is the definition of increasing sequence? So definition. What is the definition? A sequence Sn. A sequence Sn is said to be, is called increasing sequence. Is called increasing sequence. Increasing sequence is called increasing sequence if Sn is less than equal to Sn plus 1 for all n 1, 2 and so on. Sn is less than equal to Sn plus 1 for all n is equal to 1, 2 and so on. So this, that is what happened here. S1 is less than S2 is less than S3 less than and so on. Sn less than Sn plus 1 and so on. So what is this? This means second term is greater than equal to S1, third term is greater than equal to this, fourth term is greater than equal to, and so on. Then that sequence is called increasing sequence or non-decreasing sequence. For example, so what is the, we take an example, sequence 2n. Sequence 2n. So put n is equal to 1, 2, 3 natural numbers. So domain is like 2. So that is 2, 4, 6, 8 and so on. So this is the increasing sequence. So why increasing sequence? So this is S1, this is S2, this is S3 and so on. So this is the increasing sequence. Similarly, what is the decreasing sequence? Decreasing sequence or non-increasing or non-increasing sequence. Non-increasing sequence. So what is the definition of decreasing sequence? What is the definition of decreasing sequence? The definition. A sequence Sn is called decreasing sequence if Sn is greater than equal to Sn plus 1, for all n is equal to 1, 2, 3 and so on. 1, 2, 3 and so on. So this can be written as, thus, हे कसं लिहू शकतो आपण? Thus, S1 is greater than equal to S2 is greater than equal to S3 and greater than equal to and so on. Sn greater than equal to Sn plus 1. Okay? So, we take example to understand this definition simply. So, general example, so that is 1 upon n. So what is the sequence here? 1, 1/2, 1/3 and so on. So this sequence is called decreasing or non-increasing sequence. Why it is? So this is S1. So this is S2. S1 is greater than S2. So this is S3. S2 is greater than S3 and so on. Therefore, this sequence is said to be decreasing sequence. Just take a note. 1. आता increasing sequence शिकलेला आहे. So every increasing sequence is bounded below. So what is increasing sequence? So this is a increasing sequence. So why it is bounded below? Bounded below का म्हणतो आपण? कारण का this is m. And definition मगाची bounded below सांगितलेला आहे. All terms greater than equal to small m. This is bounded below also. And increasing. Therefore every increasing sequence is bounded below. Similarly, every decreasing sequence is bounded above. Okay. So for example this. So this is capital M upper bound and each term less than 1 म्हणजे प्रत्येक टर्म 1 पेक्षा लहान असेल तर त्याला बाउंडेड अबाव म्हणतात. आणि ही बाउंडेड अबाव पण आहे आणि त्याचबरोबर डिक्रीजिंग पण आहे. म्हणून एव्हरी डिक्रीजिंग सिक्वेन्स इज बाउंडेड अबाव. ओके. तर हे आपलं सिक्वेन्स दुसरं लेक्चर झालेलं आहे. उद्या आपल्याला तिसरं लेक्चर पाहायला मिळेल. तत्पूर्वी तुम्ही ही सिरीज मिळवण्यासाठी चॅनेल सबस्क्राईब करा आणि चॅनेल लाईक करा. त्यामुळे तुम्हाला सिक्वेन्सची पुरी लेक्चरची सिरीज बघायला मिळेल. ठीक आहे, या ठिकाणी थांबा.